Hello everyone, I'm Xiao Gang. Let me briefly explain what we'll cover in this chapter. Using a camera to perform face detection, which is actually called liveness detection. We have a device that when it detects someone, will greet them by saying hello. That's the basic function. This function is mainly divided into three parts. The first part is to open your camera and capture one frame's RGB values. Then we convert it into an image. The first step is to obtain the video stream from the camera. The second step is to take this video stream and capture one frame's RGB values to generate an image. The third step is to send this image to iFLYTEK. Then iFLYTEK will tell us how to detect it. And on our end, we handle everything step by step. So first, let's open the video stream, right? Then I will start this video stream here. Then let's take a look at the effect. You can see, hello everyone, I'm Xiao Gang. You see, there should be no problem. Then we detect the fire body here. You can see that the fire body can be detected now. Then we block our face here. Block our face. Take a look. You see, after blocking the face, it can no longer detect the fire body. We can turn off the camera now. Of course it's gone then. You see, this might be that thing, not cleaned up. We just need to clean it up. As for this data, we'll restart and block it. It might be residual data. Okay, can't detect it now. Good. So why are there two here? Because you have one. If I'm on my laptop, I can just enable the default. But this desktop needs finer tuning. This is because your audio input device has an issue where... What is this issue? That is to say, an audio device may have a video track and an audio track. At this point, you need to make a simple switch. Turning off the camera is straightforward. Just disconnect the stream, because when you disconnect the stream, the render target is not cleared, so it will leave one frame behind. You can manually clear it yourself. This flame detection sends that one frame of the image to iFLYTEK. Then let's take a look at how the blueprint code for this is written. First, open the default. Actually, this is the excellent Matter framework. You can play video or capture audio, video streams for monitoring. All of these are streamed. For pushing streams, you can use this audio-video framework. This code has been explained to everyone. It is quite complex. There aren't many in-depth analysis, resources, or plugins on the market. This is just a simple application. Here, we are simply opening a video stream. Then we just play it out. This part here is for fine-tuning. After we open the video stream, we select a specific track. After selecting it, we can play it directly because there are multiple audio-video tracks. We use this pull. Then, this is to close the audio and video. Just close this video stream, and this is posted on the official website. Just search for it directly. Just search the official documentation. Then this is where we actually do the capturing a frame from the video stream. Then send it to iFLYTEK. Then here, this parameter means this material. We captured this texture, this material, draws it onto our render target. Then after drawing it, we read from the render target, get the RGB values inside, then use them to construct PNG image data. After the construction is complete, we take this PNG binary data and send it to iFLYTEK. Here we have the key obtained from iFLYTEK. Right, this key information. I used 3 strings here to avoid leaking the key. Right, so we temporarily write 3 strings here because writing it here would be line text. Right. Then after success or failure here, we will receive the corresponding information. Then success reduces to the combined skin. Failure does not reduce to the combined skin. We won't print this information because there is too much information. Because of this facial recognition, it will tell you how many faces there are and where they are located. But our actual need is just whether there is a face or not. And this is equivalent to the entire operation of this part because it's all done using this asynchronously, using this method. We can of course connect it into a single line. If you connect it into a single line like this and you want to make it asynchronous, then when you perform this action once, it is actually very slow. It might take tens of milliseconds. The entire chain might take 1 or 2 seconds in total. That's also quite normal. Then it will block your main thread, so you cannot do it within a single frame. You must follow our previous step-by-step approach. Let it execute. After it finishes, call back to the main thread. Then the main thread can proceed to the next step, then call back again. Okay? This is the overall framework of our entire camera liveness detection process. Actually, this part is simply an upload. To upload this image data to the server, Right, that is us locally obtaining this image data. Okay, so we should first guide everyone to write this image thing, then guide everyone to write this node. After that, you can take a look at the code we need to write. If we need to write code, I might need to find it like this. We need to export, and it is here, Shiogang picture. Inside this, there will be a here, there is a tune picture. The code is here. I might have already opened it. If it's open, let's close it, because you can open two. Opening two might cause read-write conflicts. Then it should be this one. Okay. Then you can see, actually, there are two plugins. One plugin is this, the picture plugin, right? And another plugin is actually the iFLYTEK link plugin. You can see there is an additional dependency here. Then later we will take the plugin's interface and provide it to everyone to write one, because we still have several interfaces later. We'll write a separate plugin for it. This way, it's convenient for everyone to learn. This way, there's no need to rely on external courses or plugins. As for the structure, actually, you can see these logs. And this type, we haven't written anything in it, because this picture, actually, we can later integrate it into many image tools. There is no time to do this integration. Then, we mainly wrote this procedural blood action thing, and through it, we complete the corresponding resource, release, and execution. This requires some blueprint objects to do. Similarly, this TP library is also empty. We mainly wrote a class like this for it. Okay, so we will briefly conclude this lesson here. Thank you, everyone.